So this is a talk about telescope restoration project I've just basically finished a couple months ago. McMillin telescope was at the University of Ohio, the 12.5-inch pure objective Warner and Swasey mount plastic refractor. This is the observatory that was built for it and did pretty well. And interesting research was done there. They did some spectrometry. But by 1975, the dome had dissolved. See through the pieces of the dome that had fallen away. And the telescope was removed, refurbished. Union Carbide, a group of volunteers that worked at Union Carbide, took on the project of sort of cleaning it up and getting it back together. And then about 25 years ago, a new observatory was built for it in Tiffin, Ohio, a civic group called the Tiffin Rangers, local potato chip magnet. All right. Donated the money. So, interesting part about this story is it was rescued for a project in New York. So, a group in New York called Pioneer Works, it's in Civic Center, but they also have a science component. And the scientist who leads their science section is a astronomer, Jan 11, and she grew up using a 12-inch Alvin Clark refractor in Columbia. That was the experience that she decided she would like to bring this place. And this is kind of a view from the rooftop. You can actually see the Statue of Liberty from the roof of their building. And I suspect that cloudy days and cloudy nights, we're going to be looking at the people picking their teeth in the top of the statue. But the idea is to give talks and lectures and do observing. So why would you build an observatory where it's so big in New York City? Well, so the people are. The most used telescope in the entire world is the 12-inch Zeiss refractor, Griffith Observatory in Los Angeles. Over 4 million people have looked through the telescope. So that says that a telescope in a bright location is still extremely useful because you have more people to look through it. You can telescope in the middle of nowhere where the sky is great, but there's nobody there. So here's what the telescope looked like. The job of restoring it was put out to bid. I was asked to bid, and I didn't bid on it. I had restored a 10-inch myself. I knew exactly how many hours. Well, I didn't know how many hours. I knew how much work it was. And I put in a bid, and you never know exactly how long it's going to take. You're just committed to do it. It turns out I was the only bidder. So the telescope had been refurbished in the mid-'80s. It was in reasonably good condition, but corrosion was starting to get stuck back. You can see. And these Allen head cap screws certainly didn't exist in 1895, 1960-ish. You can see the rust taking over, where the paint wasn't quite as robust as it needed to be. This is the objective lens. It's an unusual lens. It's called a photovisual objective. It had interchangeable front elements. So this picture, you can see, this is the second element, and you can see the clamping mechanism for this telescope only had the visual part, shift the color correction, green into the blue, for photographic use. So it's basically all there. It just needs a lot of attention. One of the things you figure out pretty soon is that it's an extremely robust telescope. 12.5-inch telescope, a C14 weighs maybe 55 pounds. This weighs 7,000 pounds. That's the focuser, which is probably almost as much as a C14. So, yeah, I did know how much it weighed. So this is the worm gear, which obviously needs attention. These, and if they're not intended to fill up with water, condensation, and get ruined. Did make a new stainless steel worm for it. So now it's time to take it apart. This is my older son David helping out. We spent a week there, taking it apart, tacking it up. This is sort of the early stages, taking the telescope tube apart. The upper section of the tube has to be very secure so you don't crash the telescope on yourself. We get both ends of the telescope tube off, and the local guy with what's called a telehandler, which is like a forklift telescoping boom, and he said he could lift it. We took it out piece by piece. It did work out, and he was also able to put the pieces into the truck very nicely. Didn't have to shuffle them in. And we drove back from Ohio to a shop I rent in Waltham, Massachusetts, where my landlord is a friend, and he has a lot of old machinery, and so this stuff fits right in, but it does take up space. And it was time to get to work. This is my younger son, who helped out a lot. Cleaning and restoration work. I had to buy a forklift to deal with the pieces of time. So, but this is an example. All the screws that hold the tube onto the telescope. All the little screws have to be cleaned and polished. The same thing with the focuser, everything else. So anything you can turn in a lathe, much easier to polish when it's spinning. This is that stick out. Eventually, you get it cleaned up and lacquered. This is the center section of the tube. It's cast iron, weighs about 150 pounds. They custom stand, and so that we can laser clean it, sandblast it, and paint it. This is what the rear section of the tube looks like. The bare metal. Made the pieces as we handle them. So one of the interesting and complicated things about these telescopes is the Warner and Swasey big into gears, and they weren't afraid to make complicated gears. So this is the gear that transmits the fine motion. There's a knob at the eyepiece end. There's a locking knob and a fine motion knob. And that control motion has to get around the declination axis. And you have to have these concentric gears. They're actually split in two to install them. So I would be reluctant to take on the job of making one. This is the main RA bearing, the lower one, Babbitt bearing. Actually has ball thrust bearing, which is kind of interesting. It's an early telescope. These are anti-friction rollers. Oh, the way this works is pretty sneaky. So the shaft, the polar axis that goes through these bearings is 4 inches in diameter, and there's a ton mass resting on it. There's friction, finite friction. What this does is these rollers take the weight off the main bearing. It wears a little less. And also by having a big roller with a small shaft, you can't change the coefficient of friction. You change how far it goes. So by using these rollers, you're reducing the motion down to this half-inch pin. So the apparent effort is diminished. This is the equatorial casting after being cleaned up. Yeah, on the left, there's a dovetail. There's a dovetail slide, and all that does is hold the worm gear. That whole linear slide, it's like a cross slide on a blade. All that does is allow you to adjust the backlash on the worm gear. This is what the bottom of the pier looks like when it's all clean and shiny. And this is after cleaning and painting. So the guy on the left runs a paint shop in Massachusetts. We were there moving the parts around, explaining to his crew, this is important stuff. It's a telescope, and there are no more parts, so don't boot up. And it turned out his cousin was there to help us unload parts with an excavator. He said, "Oh, one of my relatives in the old country, Ireland, had something to do with telescopes." It's like, "Oh yeah, how's that?" He goes, "Well, Parsons, his name is Parsons, was the Leviathan of Parsonstown, right? Earl of Parsonstown." So we could not establish the connection, but it could be that this guy's highly evolved from a very prominent telescope lineage. So the back of the truck full of telescope parts. Then I'm sticking this. This is part of the focuser. So the focuser has a quick connect, like a nitron bayonet sort of thing. But the way they implemented it was with interrupted threads used in like gun breeches, ship gun breeches. That little groove holds a mating pin that locks it in place. So here's the mating part. You see, it also has the interrupted threads, so you can put this in and give it like a eighth of a turn. Puts it in place, and that pin guides it. Very sneaky stuff. We're showing us. So, although the telescope as a whole and the objective are excellent and work as well today as they did 30 years ago, eyepieces have evolved. Angler. So, made an adapter that holds modern 2-inch eyepiece. And the way I've been doing that for these antique telescopes is to make a piece that's threaded with the same thread as the back of a C14. It's a 3 1/4 16 thread. Once you have that, then you can buy stuff that allows you to attach telescopes. That's a Bader. It's like a collet style eyepiece holder. It's much better than the little. I was reasonably familiar because I did one before. still cool looking stuff. So Warner and Swasey were tool makers. They had a large business making turret lathes and milling machines. The astronomy stuff was their avocation. And so they decided they would make telescopes. It was like that's what they put in the showroom and what they brought to the world's fairs and stuff like that. Their prestige was their way of advertising their capability. Wooden knobs had suffered. I made some nice new rosewood knobs. The finder disappeared in 1975. It's actually finder rings. This finder, another collector, Bob Hamilton, had this, and it's period correct. It's actually what you want for a finder. There it says it's here, not the right focal length, but it needed a little. It was basically all done, but I needed a tune-up. So I put new wires in it. These are 44 gauge copper wires, and this is it. Take it apart and polish, put back together. So this thing has a lot of bling. Everything is shiny brass and bronze. And I changed all of the rusty steel screws. I changed out for bronze hardware and shined them up and lacquered them. So this thing gleams like a big piece of jewelry. The finder rings, I knew what they looked like for my telescope, but they were missing. So I had to 3D printed prototypes. And I actually had them cast in bronze. That took way more time and energy. So up in Boston area, there's a number of people that are into antique telescopes, and once a year or so, we get together, and I have the group over here shop to check out the progress. Oh, there's Peter Belows in there, and Matt Considine from Vermont, and other locals that have antique telescopes. There's Roger Sennett, who's an editor for the telescope, and that's the lens. Yeah. So this is a typical part. This is like the fine motion control. Double gears is a screw, little sliding thing, and then you're taking it all apart, clean it, polish it, lacquer, put it back together, and then do it 50 more times. One of the things that I did get to do that was new to me was the clock drive was found, returned. So it disappeared in 1975. 40 years later, it was returned anonymously to the physics department, and they didn't really know what it was. Had an idea, but they didn't really know, so they kind of put it back together. It was got as a box of parts, and fortunately, Matt Considine was able to turn up the original blueprints. And it's extremely good to have them. So this is one of the around, and there's a numbered scale. Adjust them to set the speed, but to the observer, it's a cylinder with a hole in the middle. Turning it should have no effect whatsoever. They machine a little cover, and they machine it flat so you can't see it. So anybody looking at this thing without the prints, you have no idea. Complete mystery. And there are other things about it, these toggle mechanisms and stuff, tell exactly what and why. So, and why would you this is that holds the weights when it's not. But it's this beautifully sculpted thing. Anyway, they were showing off. So there's the hard drive as I got it, and you can see there's a repair there that's not quite right. And only because I had the prints was able to kind of figure out what was going on. It seems more complicated than it should be. The weights just don't go up on something. Just slightly older ones do. You see these parts are a little bent up. That is the engine turn finish. So somebody told Harry to go make this thing look nice. He probably spent a week doing this engine turn finish. Today we would take like an equivalent of a pencil eraser, large one that's got a little grid in it. You put it in a drill press and you make these little circular patterns over and over. You have to be pretty patient. The actual clock runs on these hardened steel pivots. Here's the part that spins around. You see it's got a little orange braid shoe on the drawing. It says fiber material. What the heck is fiber? Well, it turns out you can buy it today. This was way before plastic. It's not like Bakelite or something that hadn't been invented yet. The fiber is compressed cotton fiber. And it's about a millimeter of wear for 130. So I decided to leave it. And again, it was kind of all there, but it didn't help. So take it apart, straighten out the parts, clean and polish them, and you gotta get the body of the clock drive. Again, you can see this beautiful finish. So there's a handle that you wind up the clock with, and it turns this. But the trick is you don't want the telescope to stop when you're winding up the clock. So it turns out there are planetary gears inside the drum. You take this all apart, fish all the pieces out. I found because this engine turn finish is very delicate. Those little swirl marks are not very deep. Waves of light deep. So you can't like polish it with the polishing. So I found a lacquer stripper. It's a caustic solution. It removes the old lacquer. You can see the old brown lacquer. And it leaves the bronze without any effect. And I have this little countertop dishwasher, put all the parts in there, wash it. That's the lacquer. And it's a good find. So this is the drum that holds the cable. There's a set of weights that drive the clock, and you're gonna be able to wind up the weights. Well, inside the drum is a set of planetary gears that allow this differential motion between winding the clock and still continuing to run. It actually has ball bearings inside. I think it's a pretty early use from 1995. That end of the drum has an internal gear for the planetary gears. It has an external gear, actually part of the clock mechanism. And then it has a bevel gear, which actually drives the shaft that drives the worm gear for the telescope. That piece has 3 sets of teeth on it. You don't want to make a mistake on the last tooth. But basically every part is cleaned and polished. It's a little nicer. Your hands get dirty, but it's part of the process. And you arrange it all accurate. Protect the teeth and the pivots from lacquer. All the screws have to be tuned up. They've been slightly mangled over the years, so you have to remove all the burrs. Lacquer, and then this things look like clean nicely. And then you start from together. And I think it looks a lot better than it did. It's quite the thing. I consider myself very fortunate to be been able to work on this. So this is the top part of the clock drive, and that thing is like the on-off switch. There's a lever on the other side, there's a cam, and then there's two little brake shoes and pivots and all of that just to let you turn it on. So that's the clock back together, ready for the linkage. Here it is with the linkage rates. You can see the numbers engraved on the cylinders. And I built a test stand for it. Check it out too. This one wasn't. I don't see. Anyway, it runs beautifully. So I started getting interested in why does this clock drive have this strange linkage and shape? It turns out, named Charles Young, who's an astronomy professor at Princeton, figured out if the weights move in a parabolic path instead of a circular path, the clock becomes isochronous. In other words, the speed does not change with load. It's like 1 part in 5,000. Very sneaky thing to do. And he worked out the math. I have not digested it all. So this is, let's see. Yeah, so this is in German, a fascinating book, Ambron. And then a friend of mine translated. So I'm sufficiently interested. Let you loose at this, and you can tell me how it works. But this was all calculated, force of gravity of the tube of the Earth and everything else. It was not, wasn't just some mechanic building something looked like it should work. I did not know that it was that complicated. And after seeing the blueprints and getting a couple of clues, I started digging into it. And this is a short explanation. I'm not going to dwell here, but very sneaky stuff. These guys are not fooling around. It's like mathematics embodied in. The drive weight setup. Interesting story. So this is the mechanical setup. There's a pulley for the cable. The cable comes off the drum, goes around this pulley, gets it fastened back up. And you put weights on here that generate enough energy to drive the telescope. The idea is you want a little more energy than it takes to drive the telescope. That whole governor mechanism in the clock drive slows it down, uses up that extra energy, regulate the speed. So this stuff was missing from Ohio. It turned out that my telescope had this stuff came along. My telescope was in Beloit, Wisconsin, 1916. In the 70s, the clock drive was updated to an electric motor by Warner and Swasey. They took that clock drive, sent it to Warner and Swasey. They took the fly ball governor out and put an electric motor in this years. They didn't throw the weights out for some reason. A fellow named Dave Garroway, old timers maybe, first host of the Today Show, bought this telescope. My telescope I have now from Beloit, and set it up in Scituate, Mass. And members of the Amateur Telescope Makers of Boston used to go use it. Pictures from that era. It was then sold to a Pennsylvania, Keystone College. Dave Garraway didn't throw the weights out. At the Keystone College, they built a new telescope for the original Alvin Clark lens. They didn't throw the weights out. They sold it to a collector, Bob Hamilton. I bought it from it. He didn't throw the weights out, even though there was no need for them since 1967. I didn't throw the weights out. And now the need for them here. It's like, where are you going to find that? There was a match made in heaven. I donated the weights to. Here's the photos. It's absolutely mesmerizing to watch because people today don't see this stuff. It really draws you in. So the weights fly out and it grabs that drum at the top, the little brake pads. Rub on that and regulate the speed. No, that's the correct speed. No, it turns out the telescope will run for like an hour with the weights falling like 5 feet. So 100 pounds of falls 5 feet. In an hour, you work it out, it's like 2 million horsepower. And maybe 10% of that goes into the brake. So driving the telescope. It's a remarkably small amount of energy. New finder brackets, cast in bronze. I don't want to go into it. It was a very long and expensive process. So we cleaned the lens, we took it apart. I did measure all the pieces. We have now the optical prescription. And then it was time to pack it up and bring it to New York. So I made a cart to safely carry this without packing all the 2 years. 2 years. So I had bought this like pickup truck box to bring the parts from Ohio, and then filled it up again as a stuff back down to New York. That's the equatorial head. So, today you look at an equatorial map, whatever, and it's just a tiny replica of it. So this is like a ton. I wonder, it's a great thing. This is not adjustable over a very wide range. It turns out Brooklyn, New York is 0.6 degrees north of Ohio State. Built the whole thing by 0.6 degrees near the polar line. And time to load up all the parts again. Another 7,000 pounds of parts. All strapped down. Went down to New York and started unloading. They did have a nice forklift there. Somebody that knew how to use it, so that was excellent. And this thing is nearly balanced. So it will sit there, but if you were to accelerate quickly, it would fit over some. Added his weight to help balance it out. And we reassembled the tube on display to act as a exhibit for fundraising, building a display case for these. And I think that's a pretty good looking telescope. And so when this is in use, draw people's attention, everybody knows which end to look into, and make a great showpiece for the. These rods were bronze rods. I replaced all. So it should be rust free for the next. And after a long day of driving and moving, we got a nice dinner. Hamburgers are $30 an hour. It's just a different world. It's just, yep. No, I gave them a price and I stuck to it. I did not do it for cheap, but I had actually tried to add up the hours involved, would have blown the budget. So it's one of those things where you get started and you have to ignore how much time you're spending on things. And you have to just say, this is going to get done proper way, however long it takes, it's going to take. That's just it. That's the deal. Yes. A little bit. It is. You get, it's not worth trying to copy now. It's on.
To the satisfaction.
It is. It's very satisfying. I like working with these old beautiful machines because it's like communing with the machinists and the designers who these guys are masters. They're at the top of it. They weren't on a budget. And when the boss came by and said, make it look nice, guess what? They did. Oh, it's industrial art. In the true sense of the word, it's what steampunk aspires to be. This is the real thing. Pressure gauges. It's like, this is the real stuff.